A semicircle and a circle are placed inside a square with side of length 4 cm as shown. A semicircle and a circle are placed inside a square with sides of length 4 cm. The circle is tangent to two adjacent sides of the square and to the semicircle. The diameter of the semicircle is a side of the square. In centimeters, what is the radius of the circle? Express your answer as a decimal to the nearest hundredth. So that's a math counts sample problem. Let's look at how to solve this. Now first see what is the information given to us. Information given to us is that we have a square of side 4 and let us say this is the center. Then in that case we know that this length is equals to 2. Diameter is 4, so the radius will be 2. Now let's try to locate the center of the circle and let's join them together. Let's join them together, and we know that whenever we have touching externally, then the distance between the centers will be sum of the radii. So this part is equals to 2 and this part is equals to x. Now the circle is also touching the two sides. So we'll have 190 degrees here and 190 degrees here. Then this becomes a square with side of x. Now we need to find out x value. For that what we will do, we'll drop a perpendicular from this point to here, and this is a right angle triangle. So I'll try to find out what are the sides of those right angle triangle, then we can solve the problem easily. So let's go ahead and draw the right angle triangle roughly. Now let us say that is our right angle triangle what we have. Now this height, suppose we want to find out height of the triangle, we want to find out. We know total is 4 and we are subtracting x. So left out will be 4 minus x. So we can say that this is 4 minus x. Then total is 2 and this part is x. So this small part will be 2 minus x. So 2 minus x. And the distance between the centers, which is the hypotenuse of our right triangle, that is 2 plus x. So we can write down this is 2 plus x. That's it. Now we know it's a right angle triangle, so we can apply Pythagoras theorem and find out the value of x. Let's go ahead and write down. By applying Pythagoras theorem on this triangle, we will have 2 plus x whole square equals to 4 minus x whole square plus 2 minus x whole square. Or can I just bring that 2 minus x to this side so that I can apply the formula a plus b whole square minus a minus b whole square is 4ab. So left side will have 4 into a into b is equals to x square minus 8x plus 16. Simplifying that, we get a quadratic equation x square minus 16x plus 16 equals to 0. So we'll use quadratic formula, and we know that ax square plus bx plus c equals to 0. Then x is given by minus b plus or minus under root b square minus 4ac divided by 2a. So what is our a, b, c values here? A equals to 1, a equals to 1, b equals to minus 16 and c equals to plus 16. So let's apply the formula. We have x equals to minus b, that is 16, plus or minus b square 256 minus 4ac, that is 4 into 16 64, divided by 2a, which is equals to 2. This will be 16 plus or minus square root of 192, which can be written as 8 root 3 divided by 2, which is equals to 8 plus or minus 4 root 3. Now we know certainly that the value of the radius of the circle should be smaller value. So it will be 8 minus 4 root 3. 8 minus 4 root 3 is equals to 8 minus 6.928, which is equals to 1.072. Now we have been asked to express your answer as a decimal to the nearest hundredth. So we can write the answer as 1.07 units. Centimeters, because we know everything is in centimeters. So let's have a recap of this problem. Interesting problem. We have been given that a semicircle and circle are placed inside a square with sides of length 4 cm as shown. The circle is tangent to two adjacent sides of square, and to the semicircle, the diameter of the semicircle is a side of the square. In centimeters, what is the radius of the circle? Express your answer as a decimal to the nearest hundredth. So, the concepts what we have used to solve this problem is that at point of contact, the angle between the radius and the tangent is always 90 degrees. First concept. Second concept, if two circles are touching externally, then the distance between the centers equals to sum of their radii. These are the only two things which we have applied other than Pythagoras theorem on right angle triangle. So with the help of that, we are able to find out that the radius of the circle is 1.07 centimeter.